Greetings everyone, and welcome to the next video in my lecture series on differential equations. In this video, I will introduce the concept of a system of linear first-order differential equations. As you can see, I've written out a definition here. A system of linear first-order differential equations can be written in the form vector capital X prime of t using the rather terrible notation of prime, meaning the derivative of the vector x with respect to time, and that's equal to capital A times capital vector x of t plus another vector capital F of t, where A is an n by n matrix and x of t and f of t are column vectors in Rn. In this video series, we're only going to look at 2 by 2 matrices. Now, if f of t is equal to 0, we say that the system is homogeneous. Now, that was a bit abstract, so let's go to an example of just how to work with these things a little bit. So I'm just going to scroll down. I have already written out our first example. Example, rewrite the following system of differential equations in matrix form. So we've got a system here where dx dt is equal to 4x minus 7y, and dy dt is equal to 5x. So let's start writing our answer. If you take a look at dx dt and dy dt, that's just, if you think of the derivative with respect to time as an operator, that's just operating on the vector xy, and that's going to be equal to some vector times xy. And if you remember your matrix algebra, you take this row and multiply by this column, and that's going to give you the entry on the left. And similarly, if you take the second row and multiply by this column, you're going to get this entry. Of course, you're going to be wrapping in the derivative as well. So that was a fair bit of markup. Let me just get rid of all that markup so that it's a little easier to see what's going on here. There we go. And so this works exactly in the way you'd expect. If I write the coefficients of my matrix, provided that everything lines up nicely, then when I multiply this row by this column, I'm going to get 4x minus 7y. This gives us the top right-hand side of the equation, and that's going to be equal to the derivative of x with respect to t. And similarly, we're going to have dy dt is equal to 5 times x plus 0 times y, and that just gives us our system. Now, we were using capital X's before, so let's go ahead and use that notation. So then the left-hand side just becomes x prime of t is equal to, and this is going to be our matrix A that we were using before, 4, negative 7, 5, and 0. And then the column vector xy is just going to be vector capital X. And if you like, you can write for completeness, where vector capital X is equal to x, y, the column vector xy. And that's it. Of course, we're going to be solving these later, but this is just rewriting it in vector form. Similarly, I've just written out another example. We can see that we've got a system where dx, oh, that should be a t. Oops. Let me fix that. Where dx dt is equal to x minus y, dy dt is x plus 2z, and dz dt is equal to minus x plus z. And we can rewrite it in matrix form. I'm just going to fill in the entries here. We want our top row to be all the coefficients on the right-hand side with x and y and z. So we have a coefficient of 1 on x, negative 1 on y, and 0 on z. That's looking at this first equation, the right-hand side of the top equation. looking at the right-hand side of the second equation and writing down the coefficients, we've got 1x, no y's, and 2z. And then looking at the last one, we have negative 1x, no y, and 1z. And that's it. Now what we haven't done is a non-homogeneous case. So I'm just going to scroll down and write out one of those. Let us suppose that we have dx dt is equal to 4x plus 2y plus e to the t, and dy dt is equal to minus x plus 3y minus e to the t. And we'll put a grouping bracket together to show that that's a system. Writing our answer down, then capital X prime is equal to a little 2x2 matrix here times x plus another little matrix, which is our f of t. And you can write that in two ways. I'm going to first choose to write it actually, I'm going to pull out the e to the t's here. So I'm going to first look at these entries here, the right-hand side, the 4x plus 2y. That'll give me the first column of my table, first row of my table, sorry. So I'm going to have 4 and 2 there. I'm then going to look at negative x plus 3y in order to give me negative 1 and 3. And then finally, I'm going to look at these entries here. That's going to give me a positive 1. I suppose I should use red to be consistent here, and negative 1, or alternatively, if you prefer, you could actually just write it out as e to the t and negative e to the t inside rather than having factored out the e to the t. Really, it's up to you. Okay, that's our little lesson on how to write these in matrix form.